Let's think through what's under the black box. So we have a black box and we have our physical problem. We are determining what the user inputs are, geometry, etc., based on the physical problem. And the tool uses these user inputs to figure out what is a mathematical model to be solved. The implication is that the tool is not solving a physical problem, it's solving a mathematical model of the physical problem. And that is based on some key physical principles. It might be equilibrium, it might be conservation, as we will see. And also there are assumptions embedded within the mathematical model. So the most fundamental thing you want to know about the simulation is what is a mathematical model being solved, what are the physical principles on which it's based, and what are the assumptions embedded in that mathematical model. And then the tool will obtain a numerical solution to that mathematical model and get selected variables at selected points. It's not going to calculate all the variables directly, it's going to calculate selected variables. In a solid mechanics simulation, it'll be displacements. In a fluid mechanics simulation, it could be pressure and velocity, etc. And we'll look at that later. And it's also not going to obtain these selected variables everywhere. It's going to obtain it only at selected points. And these selected points might be corners, it might be mid-sides of each of these sides, when you divide the domain up, which we have to do using a mesh, or it could be the centers of these little elements or cells. So we need to know, in the simulation, what the tool is calculating directly and at which points. Everything else is constructed from those selected variables at selected points through a process called post-processing. The color pictures, they are generated through the process of post-processing. When we are in the tool, it's important to separate out what we are doing under the category, are we affecting the mathematical model, are we affecting the numerical solution procedure, or are we affecting post-processing? And we'll do that as we are going through case studies in the answers tool. Also, one can look at the physical problem and perform some hand calculations. And these hand calculations, for instance, might use approximations of this mathematical model. It might be based on a totally different mathematical model. It might be based on empirical data, etc. And I'm using the hand calculations term very broadly to indicate, we need to do some kind of calculations or estimates of what the results are likely to be before we get into the tool. And then we can compare our expectations to the results. And ideally, one would also have experimental data to compare our results to. Though these days companies want to minimize or even eliminate the experimental data that needs to be collected because experimental data, doing that is expensive. Before we get into, in the tool, in all our case studies, we will do a pre-analysis step, that's what I call it, which will stimulate us to think through what's under the black box. So I'm going to talk about the pre-analysis step next.